Hi guys, hey, happy Wednesday. Hey, just want to start with just a quick overview of the question that you guys ended last unit with. So if we take a look at this, it says if a spaceship, so we're assuming we're in outer space, fired a cannonball into frictionless space, what diagram above, or below actually, shows the forces needed for the ball to remain at a constant velocity? So again, here's the idea, constant velocity. And for us, we're going to say that the ball is moving to the left. So let's take a look. Before we actually go through the answer, let's take a look. We didn't do very well. We did even worse when we saw it as a pre-question, but for a post-question, we didn't do super great with this. So I wanted to go over and review this main idea. So what we saw for Newton's first law, and we're going to write it again, every action, or not every action, I'm sorry, object in motion, object at rest stays that way, is this way. When the net force on an object is 0, then the object's motion will not change, meaning it will stay at rest or it will move at a constant velocity. Again, this is known as the law of inertia. So how does that help us with this? If we look at this question again, here's how that helps us. We need the net force on the ball to be 0. So if we take a look at our options, this, obviously, the net force is not 0. It has one force to the left. There's nothing balancing it out. So net force, not 0. B, not correct. C, we have two forces, one to the left, one to the right. Obviously, the one to the left is much bigger. There's, again, a net force, or the net force in this case is not 0 for C. For D, again, two forces, left and right. The left one is, again, it's bigger than the one on the right. So this circumstance is, again, another example where the net force is not 0. The correct answer is A. Even though there's no forces, right? Because the ball is already moving, for it to keep moving at a constant velocity, we just need the net force to be 0. And so that's how A is actually the correct answer, right? In frictionless space, there's nothing slowing it down. So once it's moving, it's going to keep moving, right? In outer space, all we need to do is to get something to start moving. Once it's started to move, it's just going to keep going. All right, so wanted to go over that. Again, this is very difficult for us to understand. It's much different than what we used to think, right? So, but we got to change the way that we're thinking. Okay, so here's what we're doing for our activity 7. Activity 7 is basically titled Newton's First Law Practice and Demonstration, right? So what you're doing is you're watching this video right now, right? There's 2 more things, and these are going to take us through today, Wednesday, as well as Friday. So you have 2 days to kind of finish this. The first thing is you need to just have one attempt at these practice questions, okay? You can take it as many times as you want. It's going to average however many times that you take it of your score. So if you bomb it, you can definitely bring your score up, and you're definitely going to improve your score the more times that you do it well, right? The next thing is you're going to complete a flip grid. Now, this is the first time I've ever done this. I've been told that you guys have done this in other classes, so we're going to do our best. If it doesn't work out, shoot a message on the discussion, and we'll figure it out. But what that's going to look like is here's what I'm asking you to do is do examples of Newton's first law. Basically, you're going to record a response that demonstrates Newton's first law. You're going to have 90 seconds. You're going to show 2 examples. One example of something that is moving, or an object in motion staying in motion. Another example of something at rest. Along with your examples, you're going to show force diagrams. That's going to show all the forces that are acting on it, right? Keep it simple. As well as an explanation as to why it is doing what it is doing, right? There's an example. My response is an example. Use that as a guide for what I want it to look like. Okay? And don't worry, if you do it one time and it's not correct, I will definitely respond to you and kind of give you some guidance and some pointers of how we can fix this. Again, we've noticed we're not getting it correct. I want us to try to get it correct and understand what Newton's first law is all about, right? Shoot a discussion. All right, again, if we have questions, post any questions here for really activity 7. I'll change this in terms of unit 8, but post any questions here. That way other people can respond, I can respond, and that way everyone can see those questions right there. All right. Hey, hope you guys are doing great. Hope this first week back after spring break is going well. If things are overwhelming, let me know, right? But I'm here for you, right? I'm here to help, okay? Stay safe, stay healthy, and we'll see you guys another time.